use YouTube channel, you could get your YouTube. It'll be up. It is recorded as of now. It's not live streamed. We'll record it and
Okay,
upload
ma'am.
it over there later.
Okay, ma'am. Thank you, ma'am.
Yes, yes. As soon as the topics are said once, like as soon as we go through the topics all over, we'll start our questions. I've just taken up 4 or 5 questions, but we can do as many as you want, or as like if you have any specific doubts, we can do that. Okay. Maybe there's a little bit of difference based on uh, when I studied and when you guys are studying, but then still the concepts are same. So we can go like that. Okay. So, okay. Starting. I hope you guys remember. Week zero is just what is the probability distribution. Week zero, we are going on with the discrete distributions that we have, and what are the conditional distributions, or what is the probability and all that stuff. That's what week zero is consisting of. So, what is a probability? Probability distribution. You have primarily what is a random variable. Random variable is nothing but something that denotes the possible outcomes of a random experiment, right? So random experiment is where you're conducting an experiment, you know what are the possible outcomes, and you have a probability associated with each of the possible outcomes, but you don't particularly know what is the outcome of that experiment. You can just see these are the possibilities, you don't exactly pinpoint this is it. Each of it has a probability associated with occurrence of it. Such experiments are called random experiments, and a random variable is one which takes the outcome of those random experiments. Okay, all the possible outcomes associated with it, and the probability associated with it. When you list it out as a table or when you write it out as a function, what you get is called a probability distribution. Now, why is probability distribution important? Probability distribution is important because it helps you to uniquely identify the characteristics of a random variable. Okay, random experiment as such, we said it behaves oddly, right? We don't exactly know what is there. So to know the characteristics behind it, to know its behavior, is why we need a probability distribution. Now, if you have a probability distribution, you can actually find out almost every of its characteristics, basic things like average, or how much scatter is there in the data, or is it symmetric or not. So such things, all of such things could actually, what is the minimum value, what are the quartiles of it, all such characteristics we could identify from a probability distribution. Now, what are the basic probability distribution? I guess this is something that you're importing from week zero content. It is importing from stats 1, right? So the basic discrete distributions that we have already studied are binomial, Poisson, geometric, and uniform. These are the important ones that we come across repeatedly. What is binomial distribution? I'm just stating the characteristics. Okay, there are two parameters for a binomial distribution, n and p, where n denotes the number of trials that you're doing, and p denotes the probability of success. And for a binomial distribution, you only have two possible outcomes, right? You don't have more than two possible outcomes, and the probability of success there is p. So automatically the probability of failure has to be 1 minus p. Such experiments are actually called Bernoulli trials, and when a Bernoulli trial is repeated n times is when you get a binomial distribution. Next goes for Poisson distribution. Poisson has a single parameter called lambda. It is usually used to denote rare events, right? Like, okay, here I've written an example of number of accidents, but you can see probably in a page you can find out in a printed book. This is one of the standard examples that is used to explain Poisson distribution. So in a notebook or in a printed book, you can probably find one mistake per page, but when you take the whole book or something, the number of mistakes are going to be infinitely small. The probability of occurrence of a mistake is very small. Such such rare events are usually characterized by a Poisson distribution. And geometric distribution is where you continuously repeating the experiment until you get the first success. Okay, And an extended version of geometric distribution is called negative binomial distribution, where you can observe the rth success in whatever trial, in the sth trial, or the probability of occurrence of the, for example, third success in the fifth trial. Okay, such things when you want to obtain not the first but the rth success in further trials. And uniform distribution is okay, and geometric also has just one parameter, okay, p, the probability of success. And uniform distribution is where you have equal probability for every possible outcomes. That is the feature of a unique distributions. Sorry, that is a unique feature of a uniform distribution. Also, geometric has one unique distribution, that is, it has lack of memory property, right? If any one of you recall, it is probability of x greater than s plus t given x greater than s is equal to probability of x greater than t. Okay, this is very equation, it is just a mathematical formula. Hopefully we can actually do some problem or explore it later. Okay, if I actually come in between, if you have, you can just raise your hand. And okay, if you pink, I probably I'll not be able to reply as of now. Now, and what are the continuous distributions that you have? In continuous, you have normal, exponential, and uniform. Normal is where you repeatedly see. Exponential is also with just one parameter. Normal has two parameters. And again, uniform here also is the same thing. Just that in discrete, you have countable number of values. And in case of continuous, you have infinite values for the random variable. Now, what are joint, marginal, and conditional probabilities? Joint is when there are multiple variables and all of them are behaving together. How would be the probability change? That is what is defined in joint distribution. Marginal distribution is how alone a particular random variable is behaving. Conditional distribution is when one information of one variable or more than one variable is known. How does the probability change on an different variable? Okay, you already have a prior information regarding some, then how will something else change? Okay, this is just week one content, and it is a very theoretical part of it. Okay, just know, go by the definitions of it. We'll give more time to the problems. I'm just going through what are there. Now, what is independent variables? When two variables are there and one does not influence another, we call it independent. Identically distributed is whatever, how many ever distributions we have, if all of them have the same probability distribution, then we say it is identically distributed. And the probability functions of some maximum minimum are having usually some features, and we try to do problems with it. And is to be noted, what is to be noted is sum of Poisson with lambda 1 lambda 2 is going to be again a Poisson. If for binomial also, you have sum of binomial results in binomial if p is same across. N can vary but p is same across. And sum of geometric is negative binomial distribution. These are some results that you have to keep in mind. Okay, now, what is the difference between a PDF and a CDF? PDF was probability density function or probability mass function in case of a discrete case. That actually gave you the probability at a single point, right? At the point, what is the probability or what is the function of the probability? That is what is given by PMF or PDF. Whereas CDF actually gives you what is the probability till a point. Don't confuse both. PDF or PMF is denoted by small f and CDF is denoted by capital F. And CDF is a function which is defined from whatever the whole real line to closed interval 0, 1. It is always a non-decreasing function. And you can differentiate between the CDF of a discrete and a continuous variable from the figure itself, that if you have the CDF as a step function, that is they are disconnected and you have a step function, then you have a discrete random variable. And if it's a smooth curve, it's a continuous curve, then you are observing the CDF of a continuous random variable. Okay, these are just the results that I just said now. Sum of binomial is binomial, sum of Bernoulli is actually a binomial random variable, sum of Poisson is again a Poisson, and sum of geometric is again a geometric negative binomial distribution. Also, minimum of two or more geometric variable actually follows a geometric distribution. Okay, and I guess we have problems with this also. If x is Poisson, then y given x is going to be a binomial distribution. and y given x is a binomial distribution, then you have y is Poisson. Or if you have x and y as Poisson, then you can again say y given x is going to be a binomial distribution. Similarly, if x and y are binomial, then by the previous property, these are called additive property, you have x plus y is binomial. Now x given x plus y, the conditional distribution is going to be a hypergeometric distribution. I'm just keeping on saying, if you want to interrupt me, you can. Okay. Now, what is expected value? In the common language, whatever you call the central tendency or the average, that is what is represented through expected value. What is the issue is, instead of, we usually when we calculate average, we just have 1 by n sigma xi, right? But that is, here each of these xi's are associated with the probability. So we are taking that also into the consideration. That is the only difference. So expectation of x is equal to sigma x of f of x, and in case of a continuous distribution, it will be integral x f of x. Now these are a few properties of expected variable, sorry, expectation of a variable. Keep in mind, while problems you can actually use such property. Expectation of cx is equal to c into expectation of x. This may come across. Or this one, expectation of x plus y is equal to expectation of x plus expectation of y. Whether x and y are independent or not, okay, this doesn't matter. Such things are useful when we actually do a problem. Now, as in the other case, as in the layman terms, variance is just what the scatter of the data is, how much spread out it is, and the square root of variance is standard deviation. In terms of expected value, in general terms, what is it? It is 1 by n sigma xi minus x bar the whole square. The same thing when you are expressing it in terms of expected value, we have it as expectation of x minus expectation of x the whole square, or this is equivalent to expectation of x square minus expectation of x the whole square. I guess the second formula is what we repeatedly use. Okay. For variance also, you could use these two properties, I guess, come a lot. Variance of ax is equal to a square variance of x, and variance of x plus a is just equal to variance of x. Now, expectation of x plus y was always expectation of x plus expectation of y, but when only when they are independent can this happen. That is, expectation of x into y is equal to expectation of x into expectation of y only if they are independent. And in case of variance, the covariance is equal to 0 when they are independent. So that vanishes, and both the cases, that is when variance of x plus y as well as variance of x minus y is equal to variance of x plus variance of y. And the expected value and variance of your standard distributions, that whatever we have, I guess all of you know all this. Bernoulli has mean p and variance p into 1 minus p. Binomial has mean np and variance np into 1 minus p. These are given in your formula sheet, okay? You don't have to mug up any of it together with the PDF. All these are sheet. And covariance, the definition of covariance is, I probably use this formula a lot more. Expectation of xy minus expectation of x into expectation of y. This is the most commonly used formula for us. And correlation coefficient is covariance of xy divided by sigma x into sigma y. That is standard deviation of x into standard deviation of y. So if correlation is close to 0, we say that they variables are not much related. Whereas if it is equal to 0, then they are completely not related. That is, they are independent. And if it is close to 1, if the absolute value is close to 1, whether it's close to minus 1 or positive 1, we can just say that they are very strongly correlated. Now, what do we have in, sorry, we have Markov inequality. I guess problems with Markov inequality and Chebyshev inequality is very important. It has repeatedly come. I guess no terms have missed it. So practice upon it. No, probability of, if x is a random variable, probability of x greater than any constant c is going to be less than or equal to mu by c, where mu is the expected value of x. And the Chebyshev inequality says that probability of x minus mu, that is the deviation of a random variable from its mean, is great if the probability that this deviation is greater than or equal to k sigma is less than or equal to 1 by k square, where mu is your mu is the expected value of x and sigma is the standard deviation of x. This formula and the other one, where you have probability of mod x minus mu less than or equal to k sigma is greater than or equal to 1 minus 1 by k square. These are again repeatedly used. Just keep in mind, okay? Both of them, you will have problems with it. And in week 4 we are starting with what is a continuous random variable. So as we stated before, when a random variable can take infinite number of values, and you have a they are called continuous random variables, and they have a smooth curve in terms of CDF. Okay, when you define a CDF, you have it as a smooth curve. And what else? Probability of x is equal to x at a point is zero for a continuous random variable. At a point, you have a mass function in case of discrete random variables, but in case of continuous, it is going to be equal to zero. Also, to obtain obtain PDF from a CDF in case of discrete random variable, you just had to subtract the adjacent probabilities, but in case of a continuous random variable, you have to do the analogous operation in the continuous area. That is, you have to find the derivative of capital F of x. Okay, and the common distributions are, again, these things are given in your cheat sheet, like not the CDF value, but I guess the PDF and mean and expected mean and variance is given. So don't mug up. I have just stated it. So uniform distribution, you have equal probability throughout the range. Here the range is 0 to 1. But generally, if it is A to B, you have equal probability. So you have the probability as 1 by B minus A. And then for an exponential distribution, the here the parameter is lambda. You have mean as, again, 1 by lambda, and standard deviation also as 1 by lambda. And normal distribution, you get very basic problems. You have just two parameters, mu and sigma, and when mu is equal to 0 and sigma is equal to 1, you get standard normal distribution. Okay, this is very theoretical part. I don't think there are any theory questions much in your paper, so we can actually go by the problem part. But is there any theoretical doubts that you guys have? Any theoretical doubts?
Ma'am, can you please show the extra slide
Extras, like that was in week 3,
in
right?
week two?
Week 2. Okay, yeah, this one.
Yes, ma'am. Ma'am, can you please explain it once more?
Yeah, this one. Okay. You have
Yes, ma'am.
X and Y as two Poisson distribution. Okay. Both are Poisson random variables. Then the conditional distribution, when you know what is the value of one Poisson variable, the conditional distribution, that Y given X is actually going to follow a binomial distribution. Or,
Okay.
or I don't think you have much problems regarding this, but then, yeah, just a useful result. If we come across problem, we can see how this happens. Okay.
Yes.
Is that okay?
Thank you.
Yeah. Or if you have any activity questions where this problem is solved, we can solve that if you want.
Yes, ma'am, there was one in PYQ.
Okay. Yeah, then we could do that probably. Okay. These are just the questions that I had taken. Can we solve it together? Like, me speaking like this is not going to help you guys, I guess. So can we just do this together? I can like help you out, say what is to be done, and then probably you can do with me. Okay. So what is the first question? It says x1 and x2. Okay, who is this? I'm sorry. Yeah, x1 and x2 are two discrete random variables, and the joint PMF is given here. We want to find what are the things. We want to find whether x1 and x2 are independent, and also we want to find the probability of these two special cases. Right. Now, can anyone tell me when we can say that x1 and x2 are independent? What is the ideal scenario? Sorry.
Joint is the
Hmm. Joint
multiplication
probability
of the
is,
marginal
yeah,
probabilities.
yes, exactly. Joint probability is the product of your marginals. Now, here, when you are checking in case of PMF table, you need to be aware that every product, like every pair, has to satisfy this. That is 1 by 2 into 3 by 8 should be 1 by 4. Okay, like I was just saying, whatever you have here, into the row sum into column sum should give you your cell. Only then can we say that x1 and x2 are independent. Now here in this case, before doing anything, I guess we need to find k. How could we find k? If you have a missing value, how can you find k? What is the
Sum of all
property that
is
you
one.
use? Yeah, the sum of all the observations in the PMF table should be equal to 1. right? Every probability value should actually equal to 1. Why is that so? It is because every combination should actually result in the whole sample space, and the probability of a sample space is equal to 1. That is something that we have studied very much before, right? In probability of the sample space is 1. That is why we need the total sum to be equal to 1. Now can you tell me what is case value here? Then after that we can proceed maybe.
0.
Yes, it is actually 0. Okay, very good. um, Now, if there is at least one cell that is 0, then what can we say about the independence of our random variables? Any idea?
Cannot be independent.
Yeah, perfectly. If there is at least one cell that is 0, then you can blindly say that it is not going to be independent. So the right option is x1, x2 is not independent. Okay, x1 and x2 are not independent. So one option we have found out. Then what do we have next? We want to check f of x1 x2, sorry, f of 1 2 is equal to f of 1 into f of 2. What is f of 1 2? What is f of 1 2 from this table?
1 by 4.
Ma'am,
Okay.
ma'am, this equation will satisfy it for every element of the given random variable. No, if
But
x1
if
and x2, but if x1 and x2 are not independent, that not any of the value will satisfy project is equals to marginal.
no. It is not like that. If at least one does not satisfy, we say that they are not independent. But that doesn't mean that none of this will satisfy. There is no condition like that. It may satisfy. At times, it may satisfy. We cannot conclude like that. Okay. So 1 2 is 1 by 4. Now, what is f of 1?
1 by 2. 1 by 2.
1 by 2 into what is f of 2?
1 by 2.
See, this satisfies, right? This is equal to 1 by 4. This is 1 by 2 into 1 by 2. So this is right, no?
Yes.
Ha. Okay, just what you asked. This is right. There is nothing like if it's if it's not independent, then it doesn't mean that none of the pairs will satisfy. Let us see for this also. What is f of 1 3?
0.
F of 1 3 is 0. Okay, now this is not going to be satisfied. 0 is equal to f of 1
1 by
is,
2 into 1 by 8.
yeah, 1 by 2 into 1 by 8. This is actually equal to 1 by 16, but this is not equal to. So this is not satisfied, but there are cases which can be satisfied also. Uh, Not equal to, if I go and search. Okay, this is not equal to. Okay, this is wrong. It doesn't imply this. Okay. Good with this question? Any doubts here? I guess it's a very easy question to start with. All of you are good?
Yes.
Yes.
Okay.
Ma'am,
Okay.
once
Yeah.
again,
I just said that if at all there is at least one zero cell, then we can surely say that they are not independent. Okay. That is for sure. But that doesn't mean that if two variables are not independent, it does not imply that any of the joint will be equal to, like any of the joint will not be equal to the product of its marginals. There may be a few of the combinations which can actually satisfy this condition, that is joint equal to product of marginals may be satisfied by few of the options, okay, few of the combinations, not necessary that it is wrong in all the cases. So if at all you have a question, you have to check for all the options, don't leave it as such, do check for the options. There may be cases where it is satisfied, there may be cases where it is not satisfied.
okay,
Okay.
thank you. Yeah,
Yeah.
yes.
Okay, perfect. Now, the next question. This is, you have a probability density function given as f of x is equal to x square by k in the range minus 1 less than x less than 2. So, this is which type of a random variable? You have a range like this. So, what random variable is this?
Yeah.
Continuous.
Yeah, it's a continuous random variable. Now, what's the first part? There are three parts for this question. First is find k. Second says find the CD function.
क्यों?
And the third part says
क्या
find the
आंसर?
expected value, right? Okay,
मुझे
find k. How
मुझे
can we find k?
मुझे जाना
Using which
पड़ेगा।
property can we find k?
वो नहीं है।
ठीक है, नहीं जा सकता
जाना तो पड़ेगा।
by integrating it
Huh.
in the
मैं
range.
नहीं जा पाऊंगी
Yeah,
किसको बोलूं?
integrating in the range and
सच्ची में नहीं जाओगे?
Putting it equal to 1.
yeah, integrating it in the range of the random variable, that is minus 1 to 2, and equating it to 1, we could get what? We could get the value of k. Okay, can you guys solve? Oh, I showed the answer, yes, but still, yeah. Can you guys solve? Could you please mute if you're not speaking?
सच्ची बोल रही हूँ।
Ma'am, I think Raz Mishra's mic is on.
Yeah, he has muted now. Cool. Integral minus 1 to 2 x square by k dx should be equal to 1.
Excuse me, ma'am. Ma'am,
Yeah,
why we are using integrating here?
because it is a continuous random variable, right? The range is minus 1 to 2. So you have a continuous random variable. That is why we
Okay,
are.
ma'am.
Yeah. This is, I guess, the first one was an activity question, but this is some quiz one previous year only. But I have tweaked it a bit. It was just to find the cumulative distribution function, the question. I changed it to find find k and expected value together so that we could cover the concepts. But yeah, this is a previous year question.
Is it 3?
Yes, it is 3. All of you have gotten, or do you need more time? Okay. Uh, okay. What it says is integral minus 1 to 2 f of x dx should be equal to 1. This is the range of this particular random variable x. So f of x is x square by k. Integral minus 1 to 2 x square by k dx is equal to 1. Since k is a constant, taking it outside of the integral, you get 1 by k. Integral minus 1 to 2 x square dx is equal to 1. Now the integral of x raised to n is defined as x raised to n plus 1 divided by n plus 1. Here the value of n is 2. So what you get is x raised to n plus 1, that is x raised to 2 plus 1, x raised to 3 divided by 3 over the limit minus 1 to 2. Now applying the limit, if anyone of you don't know, in integral you apply the upper limit first and subtract it from the lower limit. So upper limit is 2 here, lower limit is minus 1 here. So what you get is in place of x, when you substitute 2 you get 2 cube, and when you substitute minus 1 you get minus 1 the whole cube. So it is 2 cube minus minus 1 the whole cube, which is equal to k. I've just taken k to the right hand side. That implies 2 cube is 8 minus minus 1 cube is minus 1. So 8 minus minus 1, you get 9 by 3 is equal to, okay, there is that divided by 3 here, which I forgot probably. Sorry. Okay, 9 by 3 is equal to k, which implies k is equal to 3. Okay, now we have to, hope all of you have gotten k. We can proceed to the next part. It says to obtain the CDF function. How do you obtain the CDF from a PDF?
By integrating.
From
So
what is the limit?
by differentiate.
No, by integrating. Integrating is the right option. But then what is the limit to integrate? What is the limit
Support
with
of
x?
x.
Not this part of x. When you integrate it over support of x, what happens is, what is the support of x here? It is a continuous random variable, right? So there is no equal to section here. The support of x is still minus 1 to 2. Okay. Now if you integrate it over minus 1 to 2, you obviously know you are going to get the value 1, right? It's a PDF. So you are going to get the value 1. So there is no point. How, what would be the limit of integration?
Minus infinity to 2.
That is again the whole range, right? There is no anything beyond minus 1. So minus infinity to minus 1, that portion of the integral is going to be 0, and you could just have probability from minus 1 to 2. That still makes it the whole range, and you will get the value 1. To obtain the CDF from a PDF, you have to integrate, but on what limit?
-1 to x1.
Yes, right. To obtain the CDF from a PDF, you have to integrate from -1 to x f of x. Okay, can you find out now? This integral -1 to x square by 3 dx.
Y
Sorry,
y y
y.
minus 1 to yeah.
Why? Because what does CDF say? CDF definition says probability of x less than or equal to x, right? We want the probability till the point x. Whatever x is, we want it till the point x. Now, that means the upper limit of your random variable. Lower limit is left free to us. So, the lower limit is whatever is the lower limit of our random variable. And the upper limit is just the small letter x or whatever point that we want to consider, right? So that is why the upper limit goes by x instead of the upper limit of the random variable.
Okay.
You guys can tell me when you get the answer.
X cube plus 1 by 9.
Okay, is that what all of you else got? I'll see the answer just now.
Yes.
Yes. Okay. So it says f of x is equal to probability of x less than or equal to x. You integrate it from -1 to x square by 3 dx. 1 by 3 is a constant. On integrating x square, you get x cube by 3. So what you have is applying the limit x cube minus -1 divided by 9. That is x cube plus 1 divided by 9. Okay. Have I written -1? No. Okay. And the final part is no doubts, right? To find the CDF. It's just after finding the limit, it's just integration, plain integration. Okay. And the last part says to find the expected value. Now, what is the expect formula for expected value of x? What is e of x?
X times PDF.
Yeah, over the range of x -1 to 2. Here it is -1 to 2. Over the range of x, you do x into f of x dx. Okay. So x into x square by 3 dx. E of x is equal to x into x square by 3 dx. What, what is expected value? What is the expected value?
5 by 4, ma'am.
Anyone else? Maybe I didn't check. Okay, I don't know the answer.
Something like
Sorry.
5 by 4, 5 by 4, 5 by 4.
Okay, so maybe it is 5 by 4. What are we getting? We are getting integral minus 1 to 2 x into x square by 3, that is 1 by 3 into x raised to 4 by 4. And applying the limit, you will get 2 raised to 4 minus 1 by 12, right? So that is 16 minus 1 by 12, 15 by 12. You can, yeah, you can cancel it out and guess using 3, you will get 5 by 4. Perfect. Any doubt in any section? In this question, is there any doubt?
Ma'am,
No.
expectation part once again.
Yeah, expected value of a random variable x when it is a continuous random variable, the formula says integral over the range of x into f of x dx. Okay, now f of x we have it as x square by 3. So x into x square by 3 over the range minus 1 to 2 dx. X into x square is x cube. So you get x cube by 3 integral minus 1 to 2 dx. 1 by 3 can be taken outside, and integral of x cube is x raised to 4 by 4. So you get 1 by 3 into x raised to 4 by 4 to the limit minus 1 to 2. On applying the limit, we will get it as 2 raised to 4 minus 1 the whole raised to 4. That is the lower limit. So 2 raised to 4 is 16 minus 1 raised to 4 is positive 1. So 16 minus 1 divided by 12, which is 15 by 12. If you cancel out with 3, you will get it as 5 by 4. Okay?
And the PDF part wasn't asked in the question.
No, not this part. This one I added. It was not asked in the question. The question was just to find the CDF. This is Jan 24. Yes, I have opened it at that. So yeah. Okay. Next question.
Ma'am, after the lecture, can you please send us the PDF of this all
This one.
solutions? Yes.
Sure. As soon as we finish the session, I'll put it in the chat. This one,
Okay, ma'am. Thank
probably.
you.
Yeah, yeah. No issues. Okay. Next question is, we have a random variable x where the mean is 50 and variance is 25. Okay. Using Markov inequality, we have to find a bound for the probability that the production will exceed 74. Can you guys tell me what is the formulation or what is asked? Probability of what is
X
asked of
greater
us?
than 74, ma'am.
Yeah, x greater than 74. What does Markov inequality say? What's Markov inequality?
And it
Uh,
helps find the upper bound.
Yes, perfect. But what's the formula?
P of x greater than c is less than or equal to mu by c.
No, it is probability of x greater than or equal to c, right? The Markov inequality is probability of x greater than or equal to c, which is less than or equal to mu by c. Not just greater than, right?
Okay, ma'am.
So what happens is greater than or equal to c, this will be less than or equal to mu by c is what, okay, I'm just writing it, mu by c. This is what Markov inequality says to us, okay. But what we have found, we have to find here is probability of x greater than 74. So this we cannot directly apply to Markov inequality. So what can we instead write this as? What is this equivalent to?
1 minus x less than or equal to 70.
No, it is still greater than. You don't have to make it to less than. You just have to make it to equal to
X
sign.
is greater than or equals to 73.
Not 73. Greater than or
Ma'am,
equal to
greater than equal to 74 minus
75.
point of x equal to 74.
75.
25.
It is actually
Yes.
75, right? X greater than 74 means the next number that we could find is 75, right? So you can directly put it as probability of x greater than or equal to 75. And now you already have mu with you. You can find the upper bound, right? Okay, just take care what is given to you and remember to put the equality sign. That's it. Yeah, and now you can find out what is the probability asked of us.
Upper limit is
Ma'am,
15.
Yes.
0.6.
Okay. What are we getting? We are getting 75 by 50, right? No?
2 by 3.
50 by 75.
Oh,
Mean
yeah,
by
sorry. 50 by 75. 2 by 3.
ma'am,
0.6.
where can I get this PDF?
Oh, this is my PDF. I'll share it. I just made it randomly. I'll share it as soon as the session is done.
Okay.
Okay? Huh. So we have probability of x greater than or equal to c is less than or equal to mu by c. And c is 75 here. So we have probability of x greater than or equal to 75 is less than or equal to 50 by 75, which is equal to 2 by 3. All of you have gotten this, right? No doubts?
Yes, ma'am, no doubts.
Okay, perfect.
And
Now
so
the
in
sec.
Markov's inequality, there is no use of variance.
No, we don't need variance here. But there is a second part of this question. So we would need variance. Don't worry. Using Chebyshev inequality, we are to find a lower bound such that the production will lie between 40 and 60. So what is the formulation asked of us? Probability of? What is asked of us? Yes.
40, 40
40.
less than
Hmm.
x,
X
sorry, less than equal to 60.
less than or equal to 60. Now, which like, okay, what is the first step to do to find the Chebyshev inequality? What is the Chebyshev inequality? What is Chebyshev inequality? Probability of?
P of modulus x minus mu
Hmm.
should be greater than or equals to k
Hmm.
sigma that should be smaller than or equals to 1 by k square.
Okay, 1 by k square. Yeah, this is the Chebyshev inequality. So we need to make this particular formulation of probability into this form to apply the Chebyshev inequality, right? At least inside the probability sign, we want it in this form: x minus mu greater than or equal to k sigma, right? So how can you change it? What is the first step to be done? What is the first step to be done?
I'm subtracting mean from
Yeah,
both
subtracting
the
mean. Perfect. So when you subtract, what do you get? 40 minus,
50
yeah, 50 less than or equal to,
x minus, sorry, but only x
no, x minus. In x also you have to subtract. X minus
minus
mu less than or equal to
60 minus 50
60 minus 50. Now, how can you write this in modulus form? Or what is 40 minus 50?
minus 10
Minus 10 less than or equal to x minus mu, which is
minus
again less than or equal to
10
10.
10. Now, how can we write this in modulus form? Probability of hmm.
Modulus of x minus mu less than 10.
Yeah, what is mu? Okay, what mu is given to you. Okay, fine.
50
Probability of x minus mu
mm,
less than or equal to
10
10. This is our formulation. And we have the other formula here, right? Probability of mod x minus mu greater than or equal to k sigma is less than or equal to 1 by k square. But we need less than or equal to form. So what is the less than or equal to form? How does a less than or equal to form change? What if this is less than or equal to k sigma? What would you get?
1 minus 1 by k.
Yeah, greater than or equal to 1 minus 1 by k square. This is what we have. Now you know what is mu. What is k sigma equal to in this in our question? Yeah, 10. And what is sigma? As per the
Standard
question, what is
deviation.
sigma? Yeah, yeah.
Variation. Variance.
Variance is sigma square. Sigma is going to be
5.
standard
Standard
deviation.
deviation.
Yeah,
5.
standard deviation is 5. Okay, so you know everything to substitute, right? You have gotten every value. You just wanted k sigma is equal to 10, k sigma is equal to 5. You will get k from here and you can just substitute into the right hand side of the probability, like to obtain the probability, right?
Yes. Yes.
Okay, then you can solve. Perfect.
And k sigma will be equal to what?
K sigma is what?
Which 10. Okay.
Yeah.
3 by 4.
Okay. Is that what everyone got?
Yes, ma'am.
Okay. Very good. So what we just did here, probability of we have k sigma is equal to 10. So you get k is equal to 10 by sigma. Variance was 25. So you have sigma is equal to 5. K is equal to 2. So the required probability is 1 minus 1 by k square, which is 1 minus 1 by 4, which is 3 by 4. Any doubt? Hopefully no. Sure. Next question.
Ma'am, you stated Chebyshev equation upside
Hmm.
that P is 40 less than or equals to X is less than
Hmm.
or equals to yes. You got it. Ma'am, how to state that? Can you show it once again?
Which one? This one?
Yes, ma'am. Can you show it once again?
No, it is just said we have to find a lower bound on the probability that the week's production is between 40 and 60, right? This is given in the
Yes, ma'am.
question. Oh, huh. So that means if x is the productions, x is the random variable that denotes the production in a factory. So x is supposed to lie between 40 and 60. That's what the question says, no?
Yes, ma'am.
So
Yes,
we
ma'am.
just wrote
But
this down.
ma'am,
Huh.
after it is equals to
After
P
this,
equals to 40 minus 50. So you have taken the mean of question 50, right?
yeah, yeah.
Okay, okay,
Because
ma'am.
we have the Chebyshev inequality as x minus expectation of x. This mu is actually the expected value of x, right? So since it is
Yes,
in
ma'am.
this form, we need to make our probability also in this form. Only then can we use this to solve, no? That is why we are
Yes,
taking
ma'am.
it as x minus mu. Okay?
Okay, thank you.
Okay, fine. So we have
And
the
this
next one. Huh,
and these
yeah.
formulas will also be in the formula sheet now, in exam.
I guess Chebyshev inequality will be there. Yeah, Markov and Chebyshev will be there, I guess.
Okay.
I'll
Okay.
check. Okay, just give me one. Like as soon as we finish our session, I'll check. It's there in the drive. I'll just check the formula sheet once and confirm. Okay. So the next question: you have a fair die which is drawn two times. A die is thrown two times. Okay, and x1 represents the number obtained on the first throw, and x2 represents the number obtained on the second throw. And z is a random variable defined as maximum of the values of x1 and x2. Okay, so what are the values x1 and x2 can take?
1 to 6.
1 to 6. Z also can take which all values? What are the
1 to
possible?
6.
Yeah, 1 to 6. Like, Z is possible for both, right? Okay, so we need to find, first square part is we need to find the probability of Z less than or equal to 3. What does that mean? We need to find, yeah, okay. How do we start solving this?
After the dice is rolled,
Mhm.
the outcome should be 1, 2, or 3. That means that.
Yeah, the outcome should be 1, 2, or 3. But for which variable? For Z. You don't get Z directly, right? On the throw. Z is just maximum of x1 and x2. You get x1 and x2 actually. How do we start this question? We need to find probability of Z less than or equal to 3. So how do we start this?
By listing out all the possible
Oh, that's a very
scenarios.
long way, right? Yeah, we can do that. It's a
For
little
the
long way, right?
first thing asked. Yes.
So, yeah, we can do seeing all the possible values. It's not too long, but still doable. There is an easier way to do with the maximum function, right?
For the asked thing that it should be less than or equal to 3.
Hmm. Yeah, probability of z less than or equal to 3 will implies that maximum is supposed to be less than or equal to 3, right? That is the definition of z. You can just substitute for the definition of z. So what do you get? Maximum of x1 and x2 should be less than or equal to 3. If I am saying that maximum of x1 and x2 is less than or equal to 3, that does mean that x1 is less than or equal to 3 as well as x2 is less than or equal to 3, right? If the maximum value is less than or equal to 3, that does mean that individually also they are less than or equal to 3. No?
Yes, ma'am.
Huh.
Yes.
So you are having independent throws, right? You are having two independent throws. So when the random variables x1 and x2 are independent, what is the joint probability going to be? When x1 and x2 are independent, what is the joint
Multiplication.
probability of x1 and
P
x2?
of
Yeah,
x1 into P of x2.
yeah, perfectly. It is probability of x1 into probability of x2. It is a product of marginals, right? But since x1 is also just the dice throw and x2 is also just the dice throw, we can say that both of them are identically distributed, right? X1 also can take values from 1 to 6 with probability 1 by 6, and x2 can also take the values from 1 to 6 with probability 1 by 6, right? So they two are identically distributed. So probability of x1 less than or equal to 3 into probability of x2 less than or equal to 3 can be written as probability of xi less than or equal to 3 the whole square, right? It is the same probability multiplied twice. So you can write that.
Excuse
Yeah,
me, ma'am. Sorry. Where this session can I like? Is this recorded right, ma'am?
yeah, it is being recorded. You can obtain
Uh,
it on Nilgiri's YouTube channel after
uh,
this
the
session is
name
done.
of the YouTube channel. I think
It's
I'm
just
going to.
Nilgiri's channel, right? I'll inform. Okay, I'll just ask and say it's actually just IIT's Nilgiri's channel. I'm not sure of
Okay.
it.
Thank you, ma'am. Yeah.
Okay. So probability of xi less than or equal to 3, the whole square. Now what is probability of xi less than or equal to 3? One that you stated at first. What is probability of xi less than or equal to 3?
3.
No.
1 by 2.
Yeah, it is 1 by 2. How did you get? What are the favorable outcomes?
1, 2,
1,
and
2, and
3.
3.
And what are the total outcomes?
Favorable upon total number of outcomes. 3 by
Yeah.
6 equals to 1 by 2.
Yeah, we get 3 by 6, which is equal to 1 by 2. Right? Now, probability of z less than or equal to 3 is probability of xi less than or equal to 3, the whole square. So, this is going to be equal to 1 by 2, the whole, which is equal to 1 by 4. And hence, or okay, this is fine.
Yes, ma'am.
Okay. Now you can solve the second part. It says that probability of z is equal to 4 is a by 36, and we need to find what is a. Basically, we want to find what is probability of z is equal to 4. Okay, this is a discrete random variable. So how do you find what is probability of z is equal to 4? What is probability of z is equal to 4 in terms of CDF? This is CDF, right? You found probability of z less than or equal to 3. This is CDF. So in terms of CDF, how can you find this? What would this be? What is probability of z is equal to 4 in terms of CDF?
Probability z less than equal to 4 minus
Hmm.
probability z less than equal to 3.
Perfect. Probability of z less than or equal to 4 minus probability of z less than or equal to 3. Okay, it will give you the mass and probability of z is equal to 4. You know already what is probability of z less than or equal to 3. Similar to this, you can again find what is probability of z less than or equal to 4. Right? And just subtract both of these. Can you try quickly?
7.
Ah, okay. A is 7. Perfect. Yeah, answer is 7. Can we just wait for others to do? 2 minutes. If any one of you are not getting, do tell me. What is probability of z less than or equal to 4? If somebody is still solving. What is probability of z less than or equal to 4?
2/3.
Sorry?
2/3.
2 by 3. Okay. Yeah, it's 4 by 6. You get 2 by 3. So it is 2 by 3 minus 1 by 2, 2 by 3 the whole square minus 1 by 2 the whole square. So you get it as 4 by 9 minus 1 by 4, which is equal to 7 by 36. And they had asked what was A, so A is equal to 7.
Why it will whole square?
Sorry?
Why whole square?
Y whole square. Probability of xi less than or equal to x is 2 by 3, right? But probability
Hmm.
of z less than or equal to 4 is probability of xi less than or equal to 4 the whole square, right?
Okay.
We want probability of z less than or equal to 4, hence the whole square. Okay, can we go to
Eh,
the next question?
Yes, ma'am.
Okay, so here is a quick one. You have a PMF table. You need to find, okay, the first one, okay. What do we need? First, we need to find A and B. Can you find A and B? What was the condition? All the values inside the joint PMF should be equal to 1, right?
1. 1.
Yeah. Can you find what is A and B? Then.
Ma'am, A and B must be 0.
Yeah, A plus B is equal to 0 is how you end up. A and B is equal to 0. Okay. So what is probability of I is equal to 1? I guess it is very simple from this table now. What is probability of I is equal to 1? That's the first question asked out of you.
4 by 12.
Sorry?
4 by 12.
Is it?
3
It's
by
Y
2.
is equal to 1. Is this one,
That's
right?
y. Okay.
Yeah, Y is equal to 1. So it's 3 by 12. Okay. Now,
3
can
by
we?
12.
Yeah, it's a 3 by 12. Perfect. Now, next is probability of y is equal to 1 given x is equal to 2. You are given that x is equal to 2. What is the probability that y is equal to 1? What is the definition of conditional probability? What is the formula?
P of y equals to 1, comma, x equals to
Ah,
2 upon P of x equals to 2.
okay.
Equals
So
to an
the
answer of
first,
1 by 2.
yeah, the first one says probability of y is equal to 1 intersection x is equal to 2. What is that probability? Y is equal to 1 intersection x is equal to 2.
1 by 12.
1 by 12 divided by probability of x is equal to 2, which is
2
2
by
by
2
12.
by 12.
2 by 12. So what do you get the conditional as?
1 by 2.
1
1
by
by
2.
2.
1 by 2. 1 by 12 divided by 2 by 12, right? So you get it as 1 by 2. And the last part is probability of x is equal to 0 in, I mean, combined with y greater than or equal to 1. So what are the possible combinations that we have here? When x is equal to 0, y could be
X equals to 0, y equals to 1, or x equals to 0, y equals to 2.
y equal to 2. That's it. Okay, so you have two probabilities. Probability of x is equal to 0, y is equal to 1, and probability of x is equal to 0, y is equal to 2. What are we getting?
5 by
5 by
12.
Ma'am,
12.
2 by 12 plus 3 by 12 equals to 5 by 12.
Yeah, 2 by 12 plus 3 by 12, which is equal to 5 by 12. Okay, fine. All good.
Yes.
Yes, ma'am.
This is my last question, at least, what I, from out of what I have prepared. An analyst is responsible for
Ma'am,
conducting. Yeah.
ma'am, A plus B is equals to 0. How is that?
Huh. That is sum of every element of your joint PMF should be equal to 1, no? So when you add up, you're already getting 1. You don't need anything more, other, even without A and B. So A plus B should be equal to 1, or respectively A and B is equal to 0. Sorry, A plus B is equal to 0. So A and B are also equal to 0. Like this is a joint PMF, right? So PMF actually says that sum of all the probabilities available should be equal to 1. Now, if you add here 1 by 12 plus 3 by 12 is 4 by 12, plus 2 by 12 is 6 by 12, plus 1 by 12 is 7 by 12, plus 3 by 12 you get 10 by 12, plus 1 by 12 is 11 by 12, and this is plus 1 by 12 you get 12 by 12, which is equal to 1, right? So you are with, even with the available probabilities, you are already getting 1. You don't need any more probabilities. If you add anything more, this will not remain a probability distribution table. So the value of A and B is 0, or A plus B is equal to 0. Okay. Okay.
Ma'am,
So,
in PMF table,
huh,
any variable or any value cannot be in negative also, right?
no, it cannot be negative. It's a probability, right? It can only lie between 0 and 1. Okay. So the question says an analyst is responsible for conducting inspections on bikes. During the inspection, analyst found that 10% of the bikes failed the inspection. X be a geometric random variable which denote the number of bikes analyst X inspect until a bike fails an inspection. Okay, the results are independent. Okay, what is the range of a geometric random variable? What is the range of a geometric random variable?
0 to
1,
1.
1, 2.
Yeah, it is for binomial, you get two outcomes, okay, like two possible outcomes, 0 and 1. In case of X, here also it is success and failure, but X can take, what does X say? Geometric random variable is explaining in which trial are you getting your first success, right? So your first success can occur from 1 to infinity. You can infinitely go on with failures, right? Maybe if your success probability is 0.05, you will end up doing the experiment repeatedly many times, not just one or two or something. So the range of X goes from 1, 2, 3 up to infinity. Now, what is the real question? The question is, what is the probability that first failed inspection occurs on the fifth inspection? Okay. So, in the fifth trial, we are getting our first success. What is the PDF of geometric random variable? Okay, you guys have it in your paper, right? So you don't remember probably.
P to the power P
Huh.
into 1 minus P to the power K minus 1.
P into 1 minus P to the power K minus 1. Perfect. What is K here?
5.
5. So, and what is P here?
P failed inspection. Hmm. 0.1.
0.1. Out. Then you have, you can solve. P into, like 0.1 into 1 minus P is 1 minus 0.1, the whole raised to K minus 1. That is 5 minus 1. And in between, to somebody who asked, yes, Markov inequality and Chebyshev inequality is given in your paper. Okay, there's the first formula of Chebyshev inequality, but still it is given. Like you get the basic first formula, the greater than or equal to K sigma form, the one that
Okay.
you wrote at first, right? Yeah, this one. You get this one in your formula sheet. Just this one. This one you can write ulta, right? It's just a reverse.
Yes.
Yeah, one form is given. No.
Missed the answer 0.05.
Is the answer 0.05? Did every one of you get 0.05? Has anyone else gotten? Anyone else? Sorry. Anyone else?
I'm getting 0.066.
Okay, we can see what is answer. Anyone else still trying, or do we look at the answer now?
And the formula is also already known. You should see.
Okay, so it's 1 minus p raised to k minus 1 into p. So you get zero point 0.9 raised to 4 into zero point 0.1. So it's 0.065 or 66. Just open up a calculator and see, right? It's simple calculation. It's zero point 0.9 raised to 4 into zero point 0.1, 0.065. Okay, this
Yes.
is all that I have prepared. Do you guys have anything that you want me to explain or put up or do something? You can just tell me. I'll put this PDF in chi-square group. Okay, I don't think we can share a PDF over here. And I'm not sure if you can access this. I'll put up the PDF in chi-square statistics group. So any doubts that you want me to do, or anything that you want me to tell you, explain or something?
Ma'am, do you
No.
have more questions?
I haven't solved any more questions, but yeah, if you want, this is one old PYQ paper. This one. I've taken questions from here only. If you want, I can share this also. This is also solved completely. You want to go through these questions?
Yes, ma'am. No, no problem.
Okay, I'll just say how to, okay, not solve everything. I'll just say how to solve each of these. So first thing is we have A person is okay. Two of them are tossing coins, and X and Y denote respectively what they observed. Okay, what is the joint PMF of both of these? What are the possible values that these both of them can take? It's a coin toss. So what are the possible values that both of them can take? Which denote the number of
Identical.
X. Sorry,
0 and
twice. Coin is tossed twice. So what are the possible values?
Head and tails.
Yeah, head and tail,
zero,
and we are
0, 1.
observing the number of heads. Yes.
0 or 1 or 2.
Yeah, we can maximum observe zero heads, one head or two head, right? So for both
Yes.
of them, yeah, both of them are tossing the coins. So the possible values are 0, 1, and 2. Similarly for Y also 0, 1, and 2. And we can actually group each of the possible 8 outcomes. We have two coin tosses. So yeah, the possible 8 outcomes for each of them. The first guy also has 8 outcomes, the second guy also have 8 outcomes. We need the combinations of it. So the first cell would say 0, 0. What does that mean? X got 0 heads and Y got 0 head, right? So the possible outcome is X got tail tail and Y also got tail tail. That's the only possible outcome possible, right? There is no other way to explain 0, 0. Okay. The next is 0, 1. That means the first guy got 0 heads, but the second guy got 1 head. Okay. Now, 1 head can either be tail head or head tail, and 0 head is probably just tail tail. So, the possible outcome goes by tail tail and tail head, or tail tail and head tail. One of these should occur. Together they won't occur, but the whole interval, the square bracket says together. So it's tail 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 head or tail tail head tail. And randomly if we take another one, X is equal to 2 and Y is equal to 1. What does that mean? The first guy got both heads and the second guy still got one head. So how can you write it? You can write it as the second guy has got both of them as head. So the outcome is head head, and for the first guy it's still tail head or head tail. So the possible outcome here is going to be head head tail head and head 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 tail. Right? One of these, any one of these will satisfy the combination 2 1. Is it okay? You can fill it up like this, right?
Yes.
Huh. And you can respectively see it's a fair coin, right? They are tossing fair coins, so probability of head and probability of tail is going to be 1 by 2. So the probability for both tail is going to be 1 by 2 into 1 by 2, which is 1 by 4 for the first guy. For the second guy also it is going to be 1 by 2 into 1 by 2, which is going to be 1 by 4. So it is 1 by 4 into 1 by 4, which results in probability 1 by 16. And if you take maybe this result, what you have again, this is 1 by 2 into 1 by 2, which is 1 by 4. This is also 1 by 4, but we have two possible combinations, right? So 1 by 16 into, sorry, 1 by 4 into 1 by 4 plus 1 by 4 into 1 by 4. So you have 1 by 16 plus 1 by 16, which we are getting it as 1 by 8. One is both of it should occur together, the other is either one of these should occur. So we are adding it up. The first case was tail head in and head head. That is, it should occur together. So we did 1 by 4 into 1 by 4. But either one of these is enough. So we are doing a addition over here of probabilities. Okay. Now, okay, you will see repeated question. Okay, this one we just discussed now. I just took it from here. So what is this? Yeah, this says X and Y are independent random variables with mean 10 and 20 and variance is 2 and 4. We need to find the variance of XY. Okay. Considering it as one variable, what is variance of X? It is simply expectation of X square minus expectation of X the whole square. Right? So using that definition, we can write variance of XY as what? Expectation of X square Y square minus expectation of XY the whole square.
Yes.
Yeah. And what is expectation of XY when they are independent?
Expectation of x into expectation of y.
And that is when they are independent, what is expectation of XY? Okay, you're getting it as expectation of X into expectation of Y. And what can we write this as? Expectation of x square, y square. What is it? It's also going
Expectation of x
to.
raised to power 4.
Yeah, it is expectation of x square into expectation of y square, right? That's how you get expectation of x square into expectation of y square minus expectation of x into expectation of y the whole square. Now, expectation of x and y are already given to you. What is it? You are given expectation of x as 10 and expectation of y as 20. So you have this part covered. What else do you need? You need just this part, expectation of x square into expectation of y square. But we are also given expectation variance of x and variance of y, which is 2 and 4 respectively. Now, using the definition of variance of x, we can obtain expectation of x square as what? Variance of x plus expectation of x the whole square is going to be expectation of x square, right? On substituting, we will get expectation of x square is 102 and variance of, expectation of y square is 404. Now you need to just back substitute. Variance of xy is going to be equal to 102 into 404 minus 10 into 20 the whole square. And variance of xy, you'll get it as 1208. And we have used one property that if x and y are independent, then x square and y square are also independent. Only if we know this, can we split this, right? X square into y square. If we don't know this, you cannot split. You just know that x and y are independent. Actually, I believe this hint was given in the question paper also. Okay. Now,
And
in the
can
next,
it and can
uh,
this question be done with the property that variance of xy is equal to variance of x plus variance of y?
no. Variance of xy is not equal to variance of x into variance of y.
And they are independent.
Even if they are independent, you can't do that. You can only do it variance of x plus variance of y can be like variance of x plus y can be written as variance of x plus variance of y. But for product, we don't have that option. Only for expectation
Okay.
can it be written as product, not in terms of variance. Okay. What is the probability distribution? What are the values that x can take from this graph? What are the values that x can take?
Minus 1, 0, 2, and 3.
Okay. With probability?
Point 2, point 3, point 2, and point 3.
Yeah, point 0.2, point 0.3, point 0.2, and point 0.3 again. Right? This is the probability distribution. We need to find the expected value. Okay. So what is expected value? Formula? Discrete case? Discrete case?
Summation over x into p of x.
Yeah, summation over x into p of x or f of x. So you have minus 1 into point 0.2 plus 0 into point 0.3 plus 2 into point 0.2 plus 3 into point 0.3. Okay? Easy question. Not really a tough one, I guess. At least I hope. Yeah, this is a CDF 1 minus e raised to minus 4x. We need to find the value of probability of minus 4 less than x less than or equal to 6. But we are given that x is greater than or equal to 0. So the first step is to divide this interval into what? How do we
Minus
need to
4 to
divide this?
0,
Minus 4 to 0 plus probability of 0 to,
6.
yeah, 0 to 6, right? That is how we need to do. And what is the first part? This part is
0, 0.
0. Yeah, 0 plus, oh, there is an x in between. Okay, sorry. Yeah, and what is this? Probability of 0 less than or equal to x less than or equal to 6.
Integration
No,
0 to
just CDF,
6.
right? You have CDF, right? So you can directly put it as f of 6. You don't have to integrate or do anything at all. Do nothing. This is CDF, right? CDF actually give you probability of x less than or equal to x.
Oh, okay.
If it was small f of x, then you have to integrate. It is given
That
that this
is
is
PDF.
CDF.
If it's
Yeah.
small,
Yeah, if it's small, it's PDF. That you are giving probability of x equal to x. This is capital F of x. That means it is giving you probability of x less than or equal to x. Okay. So you can
Yes.
directly substitute in place of x 6, and you will get it as 1 minus e raised to minus 24. Cool?
Why didn't you put uh,
Hmm.
less than equal to 0 in the first part?
Yeah, doesn't matter. We can put here. Like nothing will happen. It's continuous, right? Equality sign doesn't matter wherever you put. Still, the integral is going to be 0 to 6. No worries. Okay, so what is this? X and Y are IAD uniform random variables, and a different random variable is defined such that z is equal to x mod x plus y. Now, what are the values that mod x plus y can take? What are the values that mod x plus y can take?
0, 1,
Hmm.
and 2.
0, 1, and 2. And you can consider different possible combinations, right? And find out the probability. You can do that,
Yes.
right? You have x can take all the values minus 1, 0, and 1. Y can also take all the values minus 1, 0, and 1. Just take every combinations and see what is x plus y and mod x plus y. With respect to how many twos you have, you can write this probability. Okay, you can combine these twos and find the total PMF table. Each of these values are getting 1 by 9, and this colored one are to be combined because they are giving you the same output. Combined in the sense added up. And okay, the next is probability of x is equal to 0 given z is equal to 1. So you already know that z value is 1. Okay, so using the definition of conditional probability, how can you write this? Probability of
X is equal to 0 and
huh,
Z is equal to 1 divided by probability of
yeah,
Z equal.
yeah, probability of z is equal to 1 you have here. Now probability of x is equal to 0, z is equal to 1. X is equal to 0 in these three cases. Here you got z is equal to 1 in these two cases, right? X is equal to 0 in these three cases, and you have z is equal to 1 in these two cases. So what is the numerator?
2.
Yeah, 2 by 9 divided by 4 by 9. It's going to be 2 by 4. Okay?
Yes, ma'am.
Okay. Yeah. What is the next one? Okay. Kunal will roll a die and Sanskriti will flip a coin. Okay. X represents the number on the die and Y represents the number of heads obtained. If it is given that x is equal to 5, then which of the following? Okay, she'll flip the coin depending on what is the number obtained on the die. Okay, so if x is equal to 5, how many times the coin will be flipped?
5 times.
5 times. So what is the correct range? Y given x is equal to 5. What is the correct range?
0 to 5.
0 to 5. Now, y given x is equal. What is the distribution of y given x is equal to 5?
5 comma 1 by 2.
Yeah, 5 comma 1 by 2. Perfect. Now you have y given, okay, y is equal to 1 given x is equal to 5. Coin is flipped 5 times, you get 1 head. What is this probability? Just use the binomial PDF, okay? Like, don't go and find the combinations. Even that is possible. Put x is equal to 1 in the binomial PDF. So you get 5c1, 1 by 2 raised to 5. What are you getting? 5c1, 1 by 2 raised to 5. Divided by probability of x is equal to 5. Is anyone trying?
How will we get the denominator?
X is equal to 5. It is simply what? the die rolled, right? It's just what is the probability of of getting 5 in rolling a die?
1/6.
Yeah, 1/6.
And but it's the number
But you
of times
don't.
it's
Yeah, we
rolled.
don't have to do that. It is directly y given x is following binomial, right? It is y given x distribution is binomial. So you just have to put x is equal to 1 in this particular PMF.
If it is was not given, then
Then you know, right? If you don't know, you can just use it as y is equal to 1, x is equal to 5 divided by probability of x is equal to 5. Both will give you the same answer. The joint probability y is equal to 1, x is equal to 5 divided by probability of x is equal to 5. Okay.
yes.
Okay. Next is this one we just did, right? Z represents the maximum value. We have to find probability of Z less than or equal to 3 and A by 36. I guess you got it as 7 by 36. This also we did. It is Markov inequality and Chebyshev inequality. Okay, so this is a continuous random variable. We are given the density function. It's a part density function. In 0 to 1, the probability is 1 by 10. In 1 to 2, the probability is kx. And in 2 to 3, we have the probability is 3 by 10. We need to find the value of k. How do we find k?
By integrating over all ranges given.
And it should be equal to
1.
1. So we get integral 0 to 1, 1 by 10 dx plus integral 1 to 2 kx dx plus integral 2 to 3, 3 by 10 dx is equal to 1. Okay. It is basic integration. So you will get 1 by 10 into x to the limit 1 to 0 to 1, k into x square by 2 to the limit 1 to 2, and 3 by 10 into x to the limit 2 to 3. Now, when you apply the limit, you will get it as 1 by 10 plus 3 by 10 plus 4 minus 1, right? So 3k by 2 is equal to 1. So this is going to be equal to 4 by 10 plus 3k by 2 is equal to 1, or 3k by 2 is equal to 1 minus 4 by 10. And on solving this, we will get k is equal to 0.4. And what is the last part? Last part says probability of 1 less than x less than 2.5. So how do we split this interval? 1 less than x less than 2.5 it is. So how do we split this? Split this interval first. Probability of 1 less than x less than 2.5. What do we do? Probability of
1
huh, according to
then
the
2.5. 1 1 to 2, then 2 to 2.5.
1 to 2 and 2 to 2.5. Here you can actually do the integration with PDF. So how will you do? Integral 1 to 2 0.4x plus integral 2 to 2.5 3 by 10
3 by yes.
dx. Okay. Yeah, this is it. The question paper is actually done. Maybe do 2 to 3 question papers, PYQs. You will be good to go. You will get 100 marks in quiz 1 if you do 2 to 3 question papers and do your mock. That will be available. That's enough.
Aren't mocks extremely difficult?
Mock is extremely difficult.
In related, if compared to PYQs,
Oh,
then
okay. So then do mock and you'll be set, right? You will not have to do anything. Yeah, PDF, I can't share it here, I guess. I'll share it in the group, okay? I'll do both the PDFs in the group.
Ma'am, this PDF you have sent earlier a PDF. Send it once again. This one.
Here. Oh, this link.
Yes, yes.
Is the link working?
Yeah, yeah. It's working.
Oh, okay. Then I can share this also. I'm not. I wasn't sure the link is working. Yeah, here. This the first one was the first PDF that we discussed with a fewer questions. This is quiz one Jan 24. Every question solved. Both the same. No, the ID is different, right? Yes. I shared this one now. Okay. It's not the same. If you have any doubt, do drop in chi-square. We'll help you out, okay? To solve. If you actually have any doubts.
Ma'am, I have
Huh.
requested to be in Chi Square with collaboration with Nilgiri House Group, but it is not accepted. Then how we can find
Okay.
PDF?
Not in
I'm
that
also
group.
not
There
in.
is a members group, actually. Not in the group of Nilgiri Wala. There is just a statistics club members group. You can join there.
How
Ma'am, how
can
to
we join?
join it?
Ma'am, you will send a PDF on that group?
Yeah, I'll send it on that group only. Okay.
How to join?
Just give me a minute. Let me see where I can get this. Uh, uh, I'll put that in the chat, okay? Oh, just stop the recording. Okay, thank you. I'm just stopping the recording, okay? You're not discussing anything, right?